Okay, here is the video guide for lesson 3.2.1. When we look at the introduction slide for this second part of chapter 3, what it's going to tell us here is what other information do we need to conclude that two triangles are going to be similar. So we said that triangles were similar previously by saying that they were being dilated. One was a dilation of the other, meaning if two shapes have been dilated, that all the sides are proportional, or that all the sides had been multiplied by a common zoom factor. That's how we said that they were similar before, but what other information can we conclude today that will tell us that triangles are similar? One of the big ways we're going to show that triangles are similar is going to be using our similarity transformations, our dilation, rotation, reflection, translation. If we can use those and get these triangles to land on top of each other in our e-tools, then we know that they're going to have these similarity relationships here. So again, we're going to look for two more things today, two more conclusions to how we can say triangles are similar, other than just saying all the sides are proportional. In this first question here, it's asking us, well, okay, like these two triangles may be similar, but what would be true about their information, their angles, and their sides if they were similar, okay? And remember, this goes back to what we were doing. Well, all the sides would have to be proportional. All of them would have to have a common zoom factor. So if this side over here was 4, this side, the corresponding side, would have to be maybe 2. So then we have a common zoom factor of being multiplied by 2, but then that needs to be shared in all of the sides. So maybe this side is, let's do 8, which means this side down here would be 4. Maybe the long side is 10, and that would make this long side over here 20. So everything has that shared common zoom factor. And we also knew, looking at last week, that if the two shapes are similar, all of the angles are congruent. So the angles in the big shape and the angles in the small shape are congruent. So you can write those two things in this box here, the sides being proportional and angles being congruent. Okay, we get to this problem here, and it says, what if we know all the angles are congruent? Does that mean the triangles are similar? Do we have to actually worry about side lengths? And so we get to write our prediction. Do we think that just knowing the angles congruent, do we think that's going to make the triangle similar or not? And then we get to test it when we click into the E-tool. And so the one thing I want to show you on the E-tool, because we're going to do this throughout the lesson, is we're going to try to use transformations to get these triangles to land on top of each other. And so what I do is, instead of trying to drag it around, click on it and use the tools. So this one's reflection, rotation, dilation. And I'm going to first start by reflecting this shape. And then I'm going to translate it over so the vertices land on top. And I'm going to rotate a little bit so I can get it to line up. And then I enlarge it. And look at that. I get it to land on top of each other. Similarity transformations tell me that that's working. And so I can go back to my lesson and I say that, well, if all angles are the same, that the two shapes are going to be similar, and I can move on. So then now it's going to lead us into describing a sequence of transformations that show that two triangles that have the same three angles are similar. Okay, and then we're going to use these rigid transformations in the E-tool to describe it. And then what can we finally conclude about triangles with equal angles? And we can make a statement about their similarity there. Here we get into thinking that these shapes are not drawn to scale. How can we show that they have, or their corresponding angles are equal? So triangle sum theorem can tell us what the missing angle here is and the missing angle here is. Because they have two, we can find the third. And then we can convince him that they're similar by talking about the angles being the same. And then there's a big point here that says, how many pairs of angles do you actually need to be sure the triangles are similar? And really, you'll see in this problem that you only need 2. You only need 2 angles to show it, because triangle sum theorem tells us, okay, if 2 angles are going to be the same in both triangles, that means the third angle is going to be the same. And we did that in a previous lesson. Okay? And so when you say this, you can say, okay, I only need 2 pairs of congruent angles to say it, and you could abbreviate that with angle, angle, similarity. Just 2 A's. Okay? On to the next one. So that's angle, angle, similarity. One of the big takeaways today is that angle, angle, similarity exists and tells us that two triangles are similar. And then we get into this next part, is saying, what if we only know that one angle is congruent, but the 2 pairs of corresponding sides that make up the angle are proportional? Does that tell us the triangles are similar? So this is what they mean. Okay, we have this angle 20 and this angle 20, same angle. Okay, the side lengths that are building that angle are like the 4 and the 5. So what we see here is congruent angle 20, 20, And then we have 4 and 5 and 8 and 10. So we have a common zoom factor of 2 between those. And so we have the proportional sides, we have the angle that's equal in the middle. Are these triangles going to be similar? And so we try to do our transformations again to them. And I start maybe by reflecting a little bit, lining up my vertices, rotating it, and then I can probably expand this, and I think we're going to have congruence, not congruence, but similarity there because the transformations put one right on top of the other. And so my first thought is that this is going to be some kind of similar relationship where we have the two pairs of corresponding sides and the angle in the middle being the angle in the middle being the same and the two sides being proportional. Then I'm seeing that these look like they're going to be similar. I test it a few more times using these other e-tools, and then I draw a conclusion here saying, okay, we can call this side angle side because we have a side, the angle in the middle, and then the other side being proportional. So side proportional, angle the same, side proportional. And I'm seeing that this is creating similarity. So let's justify how we saw it and how we know that this relationship exists and that it works. And then we can say that's our second understood, and this is a big takeaway, second similarity relationship we see today. We had angle, angle, and now we have side, angle, side. And then we practice using them here and then following problems. Okay, so do we have enough information here to say that they are similar? And if you think they are similar, then we have to explain it and use what angle relationship we use. So either all the sides were proportional, so you'd have side, 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 or you'd have angle, angle, because that was one we discovered, or you'd have side, angle, side, and you'd have to explain how you got it. Same thing for the next couple. Are they proportional? Do they meet one of our similarity relationships we're discovering here today? Same one here. Think that this angle M is in both triangles. M is in the first triangle, M is in the second triangle. That can help us. Here, do we have enough to explain or enough to justify that these triangles are the same? Are all the sides proportional? And then just a learning log in your notebook today. Forgot to put a answer down here. And then just some math notes that go along with today's lesson. If you have any questions on any of the problems, I'm always happy to do a little further explanation. Just please email me, reach out, and ask.